Hello students, welcome to the statistics class. So in today's class we shall discuss the second method of finding the coefficient of correlation, that is the Karl Pearson's method. In the previous session we discussed about the graphical method or the scatter diagram method, where we are plotting the points of a given data, and based upon the direction of the points, the scatteredness, we draw a line and conclude whether the data has a positive correlation or negative correlation. The variables in the data have a positive correlation or a negative correlation. Anyways, the problem with that method is it is non-mathematical method. So drawing the line, judging the scatteredness of the points or the observations of the two variables is completely subjective. So whatever the conclusions are drawn there, they are purely subjective and they have no mathematical base. So there is a huge chance of errors in the result obtained. Hence, we adopt a mathematical procedure to obtain the exact figure or number pertaining to the correlation of the two variables. So we go for Karl Pearson's method. So this coefficient of correlation measures in one figure the exact degree of correlation existing between two variables. So using Karl Pearson's correlation, we can obtain the exact degree, whether it is higher degree positive or higher degree negative, or lower degree positive or lower degree negative, or whether it is perfect negative or perfect positive. So all these questions can be answered using Karl Pearson's method. So let us look at the formula here. It is called as the product movement correlation coefficient, and it is given by correlation coefficient of xy. So this is the symbol of correlation coefficient, and this means correlation between the variables x and y, that is equal to covariance of xy divided by variance of x into variance of y, square root of variance of x into variance of y. So correlation coefficient is equal to covariance of xy divided by standard deviation of x into standard deviation of y, because if you take root of the variance you will get the standard deviation. So covariance formula here is deciphered as summation of x minus x bar into y minus y bar divided by square root of this formula can be written as summation of x minus x bar whole square into summation of y minus y bar whole square square root. So here this is a relative measure of correlation. So relative measure means it is not affected by the units. The units of the data are not considered here. Okay, the answer will be in terms of a proportion, or if you multiply that with 100 you will get a percentage. Okay, so here x bar and sigma are the mean and standard deviation of x, and y bar and sigma y are the mean and standard deviation of the variable y respectively. So again, for further calculations, this formula has been simplified as correlation coefficient is equal to n into summation of xy minus summation of x into summation of y. This divided by root of n into summation of x square minus summation of x whole square into n into summation of y square minus summation of y whole square. So wherever there are summations, it means they are the columns. So this means summation of x into y. This entire formula is for ungrouped data. So for ungrouped data you will be given two variables x and y. So here this means you have to multiply each x with each y values respectively. Summation of x means the total of the x column. Summation of y means the total of y column. X square, you have to you have to square the x terms and then add them. Here n refers to the number of pairs of observations. Suppose in the variable x 10 observations are given, and in the variable y also 10 observations are given. So they are 10 pairs of observations. So x and y are considered together here. So 10 pair of observations. So n into summation of y square minus summation of y whole square. So this is the formula for ungrouped data, and this one is the formula for grouped data, which we shall discuss later. Now let us look at the different interpretations of the answers. So if x and y are positive correlated, suppose the data, if it is positively correlated, then the higher values of x will be associated with the higher values of y, and the lower values of x will be associated with the lower values of y. So positive correlation means both the variables will change in the same direction. So if x decreases, then y also decreases. If x increases, then y also increases. If it increases in the exact same quantity, then we call it as a perfect correlation. If it is not exact, then we call it as higher degree or lower degree, depending upon whatever it is. So higher values of x will be associated with the higher values of y in case if the positive correlation exists between the given two variables. So if x minus x bar, that is if this deviation value is positive, then y minus y bar will also be positive, and if x minus x bar is negative, then y minus y bar will also be negative. So in the covariance formula we have summation of x minus x bar into y minus y bar. So if the correlation is positive, that means both of them will be either positive or negative, which means when you multiply them, you will get the answer as positive number only. Okay. So there may be some exceptions to this. The exceptions will be more if the correlation is low. If the as the degree of correlations lowers, the exceptions will start increasing. So the product x minus x bar into y minus y bar will be positive. Therefore covariance of xy will be positive, and the coefficient of correlation will also be positive. Therefore the product moment will be higher if the correlation is high, and it will be lower if the correlation is low. So if your answer is 0.85 or anything between 0, anything greater than 0.5, it means the correlation is higher. If it is below the 0.5, it means the correlation is lower. Okay. So next, this is about positive correlation. Next we will be having negative correlation. If x and y are negatively correlated, then the higher values of x will be associated with the lower values of y, and the lower values of x will be associated with the higher values of y. So if x and y are actually negatively correlated, then higher the values of one variable results in the lower the values of the other variable. Suppose perfectness exists, then if x increases by 8%, then y decreases by 8%. This will be perfect negative. Or else if x increases, y decreases, or if x decreases, y increases. So this is called as negative correlation. So if x minus x bar, that is again the formula of covariance, if x minus x bar is positive, then y minus y bar will be negative, or vice versa. If x minus x bar is negative, then y minus y bar will be positive. There may be exceptions here. So the exceptions increases if the correlation is low. Okay. So the numerator of the formula, the correlation formula, that is x minus x bar into y minus y bar, will be negative, which will again in turn result in the negative number. So therefore covariance of xy will be a negative, and so the coefficient of correlation will be negative. Okay. So covariance will be negative. If covariance is negative, then correlation coefficient will also be negative. Okay. If x and y are non-correlated, that is if there is no correlation between x and y, the sum of the products will be positive and other products will be negative. That is sum of the deviations, that is in sum of the deviations in x minus x bar and y minus y bar will be positive as well as negative. So when you add the positive and the negatives, they will be equal to 0. So if they will be equal to 0, then it means that the numerator part of the formula will be 0. If that is 0, then the entire formula itself will turn into 0. The final answer, the correlation coefficient answer will be 0. So if the answer is 0, it means that there is no correlation between two variables x and y. Okay. Next, interpretation of coefficient of correlation. So what should be the interpretation of the answer that we obtain when we solve the problems here? Okay. So a positive value of the correlation coefficient indicates a positive correlation. If the answer is positive, it can be either 0.01 or 0.10 or 0.90, whatever the answer is. If it's positive, it means the correlation between the two variables is positive. Okay. Either it could be higher degree, lower degree, or perfect. A negative value of the product movement estimate means negative correlation. If this value in the formula is negative, either it could be 0.01, minus 0.01, or minus 0.91, it means the correlation between the two variables is negative. Okay. Next, if the correlation coefficient is exactly +1, it means the correlation is a perfect positive. So when you solve the problem, if you get the answer as exactly 1, it means the correlation is a perfect positive. If the answer is -1, then the correlation is perfect negative. So while solving the problem, if you get the answer as -1, then it means that there exists a perfect negative correlation between the two variables. So, and if the answer is 0, then the variables are non-correlated. There is no correlation between the two variables if your final answer is 0. And if the correlation coefficient value is, they have written the absolute here. So absolute means if the correlation coefficient is value is greater than 0.5 in terms of positive correlation, it means it will be of a higher degree positive correlation. Suppose if you remove the absolute here, if the answer is negative, this means this sign will be reversed and it will be written as lesser than minus 0.5. So if it is lesser than 0.5, then there will be higher degree negative correlation. Okay. So lesser the greater the value, greater the slant, and lesser the value for negative correlation, deeper the steep. Okay. The steep of the curve will be even more deep. Okay. So these are the interpretations of the answers obtained. Now let us look at a couple of examples here. So we have an example here. Calculate the product movement coefficient of correlation between the following marks out of 10 in statistics and mathematics of 6 students. So they have given a data pertaining to marks of 6 students in 2 papers, statistics and mathematics. So the maximum marks of the exam is 10. So out of 10, whatever the marks they have obtained, it has been given here. You have to consider only these two columns here. This is the roll number of the students. So this part is not for the calculation. So don't get confused here. So statistics has been taken as X and mathematics as Y. So X value 7, 4, 6, 9, 3 and 8. And Y values 8, 5, 4, 3, 8, 3 and 6. And our formula here is correlation coefficient is equal to n into summation of xy. So summation of xy, n here, you have to count the pair of the observations. So pair is 1, 2, 3, 4, 5 and 6. So there are 6 observations in x and y. So the number of pairs here are 6. So n here will be 6. Summation of x into y. So you have to multiply x into y, which they have done here. So 7 into 8, 56. 4 into 5, 20. 6 into 4, 24. 9 into 8, 72. 3 into 3, 9. 8 into 6 is 48. They have added the column here, 229. So summation of xy. Next, summation of x, the total of this column. Summation of y, the total of this column. Next, divide by root of n into summation of x square minus summation of x whole square. So here we need summation of x square, that means square the x values and then take a total of them, 255. Here summation of x whole square, we have already done the summation of x whole summation of x here, and we have to square the value here and write it. Next, n into summation of y square. So square all the terms of the y which they have done here into n, that is 6, minus summation of y. Summation of y means total of this, and they have squared here and written it. So xy total is 229. X values has been squared as 7 square 49, 4 square 16, 6 square 36, 9 square 81, 3 square 9, and 8 square is 64. The total here becomes 255. Y square is 8 square 64, 5 square 25, 4 square 16, 8 square 64, 9 square 3, and 6 square 36. Sorry, 3 square 9 and 6 square is 36. So that total is 214. So substituting all these values here, so in place of xy, they have written the value 229. Substitute 229 into 6 minus 37 into 34 divided by 255 into 6 minus 37 square, 214 into 6 minus 34 square. So 116 divided by root of 161 into 128. So that results into the answer. Correlation quotient is equal to 0.8081. Since the number here is a positive number and it is also greater than 0.5, hence there exists a positive correlation of higher degree between x and y. So from this answer we can interpret that the correlation between x and y is of higher degree positive correlation. See, now here in the numerator part, the covariance formula was the covariance resulted into a positive number. Usually denominators are always positive. If the numerator generates a positive number, then your final result will also be a positive number only. Okay. When I said exceptions, the exceptions means here the value it becomes lower. If it becomes very much low, then the correlation answer will also be low. Okay. If it is high, then it will also be high. Suppose if numerator and denominator both result into either 1 or such a number that when you divide it, it will result in 1, then the correlation will be perfect positive or negative correlation. So this is the interpretation of the answer. Let us look at another example here. So calculate Karl Pearson's coefficient of correlation for the following data. So the two variables are given here. X is 70, 71, 72, 73, 74, 75, 76 and 77. Y values are 30, 29, 25, again 25, 22, 20, 18 and 16. So these are the given values here. Now here the values are slightly, scale of the values are slightly higher here. So what they have done is they have taken the deviation method here. So let us discuss the change in the formula due to deviation here. So in the place of x you are writing u, and in the place of y you are writing v. That is the only changes that needs to be done here. So in the x column, choose any value as a assumed value, arbitrary value. Subtract all the x values from that arbitrary value. So here they have chosen the arbitrary value is 74. So all the values of x have been subtracted from 74 and written here separately. So u is equal to x minus 74. So 70 minus 74 is minus 4, 71 minus 74 minus 3, 72 minus 74 minus 2, 73 minus 72, 74 minus 1, 0, 1, 2 and 3. The total here is minus 4. Similarly, for y, they have written the deviation as v. V is equal to y minus some value here 25. So they have chosen the arbitrary value as 25. So all the values have been subtracted from 25. So 30 minus 25, 5. 29 minus 25, 4. 0, 0. 22 minus 25, minus 3. 20 minus 25, minus 5. 18 minus 25, minus 7. 16 minus 25, minus 9, which is minus 15. So u and v values. Next, u and v have been squared here, u square and v square. 16, 9, 4, 1, 0, 1, 4 and 9. The total is 44. For v square, 5 square 25, 4 square 16, 0, 0, minus 3 is 9, minus 5 is 25, minus 7 square is 49 and minus 9 square is 81. Similarly, u into v. So each value of u is been multiplied with v and then written here. So 4 into minus 4 into 5 is minus 20, minus 3 into 4 is minus 12, 0, 0, again 0, 1 into minus 5 is minus 5, 2 into minus 7 is minus 14, 3 into minus 9 is minus 27. The total is minus 78. Now here the change in the formula is correlation coefficient of xy is equal to, now we have not taken the xy here, instead of x we have taken u and instead of y we have taken v. So that becomes n into summation of, instead of xy we are writing here u into v, minus, instead of summation of x we are writing summation of u, summation of y, instead of that you are writing summation of v, divided by n into summation of, instead of x square we are writing u square, summation of u square, minus here we are writing summation of u whole square instead of summation of x whole square, that into n into summation of v square minus n summation of v whole square. So substituting all the formulas, n here is the number of the pairs of observations. So 8 into minus 78 minus minus 4 into minus 15. So divided by 8 into 44 minus of minus 4 square into 8 into 205 minus of minus 15 square. So that results into minus 624 minus 60 divided by minus square root of minus 352 minus 16 into 1640 minus 225. So that is minus 684 divided by 336 into 1415, which yields the answer minus 0.9912. So observe the answer here. It is a negative number and the answer is lesser than minus 0.5. So there exists a higher degree negative correlation between the values x and y. So here when the values are bigger, since we are squaring the variable values and we are also multiplying them, sometimes the bigger numbers will cause a kind of a tediousness in your calculation. So in those cases you can go for this method, the shortcut method, that is convert the numbers into smaller numbers and then add. It will make your task more easier. But here the only thing that you have to remember is, instead of writing x you are writing u, and instead of writing y, in place of y you are writing v. That is the only change being done here. So again, if you change the origin here, it will not be affected. Even if you solve the problem as it is without changing, if you square the x values as they are, y values as they are, if you take the products, you will still get the same result, minus 0.9912. You can try that as a homework or as an assignment. Okay, so this is the result, higher degree negative correlation. Now let us look at another problem here. So x values 300, 350, 400, 450, 500, 550, 600, 650 and 700. Y values 800, 900, 1000, 1100, 1200, 1300, 1400, 1500 and 1600. So again, since the values are, the scale of the values are very high, so the numbers have been converted here. So both the origin and the scale both have been changed here. So one value has been assumed from x, that is 500, but if you subtract it, still the values will be higher. So in order to reduce the scale here, they have divided it by 50, because the difference between all the values here is 50. Okay. Similarly, for y, they have taken v is equal to y minus 1200 divided by 100, since the difference between any two y values is 100. So x minus 500 divided by 50. So let us look at one by one. 300 minus 500, that is minus 200. Minus 200 divided by 50 is minus 4. 350 minus 500, that is minus 150, divided by 50 is minus 3. 400 minus 500, that is minus 100. Minus 100 divided by 50 is minus 2. 450 minus 500, that is minus 50, divided by 50, minus 1. 500 minus 500 is 0. 0 divided by 50 is 0. 550 minus 500, that is 50. 50 by 50 is 1. 600 minus 500 divided by 50, 2. 650 minus 500 divided by 50, 3. 700 minus 500 divided by 50 is 4. So the total here is 0. The value of u is 0. Next, for v. So v value here is 800 minus 1200, that is 400. So 400 divided by 100 is minus 400 divided by 100 is minus 4. Next, 900 minus 1200 minus 300 divided by 100 is 3. 1000 minus 1200 divided by 100 is minus 2. 1100 minus 1200 divided by 100 is minus 1. Next, 1200 minus 1200 divided by 100 is 0. Next, 1300 minus 1200, that is 100. 100 divided by 100 is 1. 1400 minus 1200 divided by 100, that is 2. 1500 divided by 1200 divide. So 1500 minus 1200, that is 300, divided by 100, that is 3. 1600 minus 1200 divided by 100, that is 4. So the answer again here is 0. U square. So squaring the u values, 4 minus 4 square 16, minus 3 square 9, minus 2 square 1. Sorry, 4 minus 1 square 1, 0, 0, 1, 4, 9 and 16. So the answer is 60 here. Again v square. So 16, 9, 4, 1, 0, 1, 4, 9 and 16. Again the total is 60. And next, u into v. Minus 4 into minus 4, 16. Minus 3 into minus 3, 9. Minus 2 into minus 2, 4. Minus 1 into minus 1, 1. 0, 1, 4, 9 and 16. The total again here is 60. You can observe that both u square, v square and uv, all of them bear the same answer, 60. So now let us look at the calculation. Formula, substitutions and the calculation. So the formula again here is correlation coefficient of uv is equal to n into summation of uv minus summation of u into summation of v divided by root of n into summation of u square minus summation of u whole square, n into summation of v square minus summation of v whole square. How many pairs of observations are there here? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 pair of observations here in u and v combined. So summation of u is 0, summation of v is also 0, so 0 into 0 will be 0. 9 into 60 minus 0, 0 divided by 9 into 60 minus 0 square. Again 9 into 60 0 square, that is 540 divided by root of 540 into 540. If you square it and if you take the root again, it will be 540. So 540 divided by 540. So the answer is equal to 1. So it is a positive number and it is exactly 1. So the correlation between the two variables is a perfect positive correlation. So the conclusion is there exists a perfect positive correlation between x and y. Okay. Now let us look at another example here. We can also observe one thing here in this example, that the amount of change in x is very uniform here. Similarly, the amount of change in y, the values of y from one another is very uniform here. Here the changes between any two consecutive values was 50, and here the difference between any two consecutive values of y was 100. So we can observe a pattern here. If any two variables, given two variables, if they have the differences like this in a uniform way, then we can obtain a perfect positive correlation between them. Next, calculate the Karl Pearson's correlation coefficient from the following data. So the x values are given here: 12, 14, 16, 18, 20, 22, 24, 26, 28 and 30. So the difference again here is uniform. Similarly, y values 36, 33, 30, 27, 24, 21, 18, 15, 12 and 9. Again the differences between the y is also uniform. Here the difference is 2, here the difference is 3. Okay, here the values are in ascending order and here the values are in descending order. So let us look at the example here. Again the example has been reduced. The values, the x values has been reduced and so are the y values. So here u values taken as x minus 20 divided by 2 and v values are taken as y minus 21 divided by 3. So we have 12 minus 20, that is minus 8. Minus 8 divided by 2 is minus 4. 14 minus 20 is minus 6. Minus 6 divided by 2 is minus 3. 16 minus 20 divided by 2 is minus 2. 18 minus 20 divided by 2 is minus 1. 20 minus 20 divided by 2 is 0. 22 minus 20 divided by 2 is 1. Similarly 2, 3, 4 and 5. Next, v values. The v values are taken such that each y value is subtracted by 21 and divided by 3. Why 3? Because the difference between any two consecutive y values is 3. So 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3 and minus 4. So here the changes here are exactly in the reverse order of that of here. Here the changes are from negative to positive. Here the changes are from positive to negative and that too exactly the same. So u square results into 16, 9, 4, 1, 0, 1, 4, 9, 16 and 25. Again here it will be 25, 16, 9, 4, 1, 0, 1, 4, 9 and 16. Both of them result into the answer 85. 85 and 85 respectively. Similarly, u into v is minus 20, minus 12, 6, 2, 0, 0, minus 2, minus 6, 12 and minus 20. Minus 12 and minus 20. The answer results into minus 80. Okay. Now let us look at the substitution and the results here. So again the formula is taken as n into summation of u into v minus summation of u into summation of v divided by n into summation of u square minus summation of u whole square into n into summation of v square minus summation of v whole square. So that is 10 into minus 80 divided minus 5 into 5 divided by 10 into 85 minus 5 square, again into 10 into 85 minus 5 square. So minus 800 minus 25 divided by 850 minus 25 into 850 minus 25, that is 820 minus 825 divided by 825. So the answer here will be exactly minus 1. The answer, the number is negative and the digit here is 1. So minus 1, which means there exists a perfect negative correlation between x and y, is what we interpret from the given problem. So this is all about the Karl Pearson's correlation coefficient for ungrouped data using both direct method and shortcut method.